Good morning, students. It gives me an immense pleasure to talk to you students through video presentations like this as usual. The topic which I have chosen is Rolle's theorem, the statement and its proof and its application in one or two problems. Before going into the details of Rolle's theorem and its applications, it's better for you to recall one basic rule. Okay, if a line, let us say, okay, let this line be L. If L makes an angle theta with the positive direction of x-axis, then M is equal to tan theta is known as the slope of the line L. Let me just repeat. If a line makes an angle theta, this is called angle of inclination. The angle made by a line with the positive direction of x-axis in general is known as its angle of inclination. Okay, then tangent of that particular angle of inclination is known as the slope. That is known as the slope. Let me repeat. If a line L is given and if it makes an angle theta with the positive direction, not this one, this angle, okay, with the positive direction of x-axis, that is known as angle of inclination. Then M equal to tangent of that value, tan theta is known as the slope of the line. Now if I am going to think about simply x-axis makes angle 0 degree with itself. Therefore slope of x-axis will be is equal to M equal to tan 0 degree is equal to 0. Similarly, slope of any line parallel to x-axis is equal to, again, tan 0 is equal to 0. If you think of a line parallel to x-axis, the angle made by that with x-axis is 0 degree. Okay, the y-axis makes an angle 90 degrees with the positive direction of x-axis. Therefore, slope of y-axis will be equal to tan 90 degrees. Sorry, which is not defined. Sorry. Then any line parallel to y-axis, okay, slope of any line parallel to y-axis is equal to, again, tan 90 degrees, which is equal to not defined. Normally in some books they will say it is infinity. It's more refined to say not defined instead of saying it to be infinity. Therefore, slope of x-axis is 0, slope of any line parallel to x-axis is 0, and slope of y-axis is not defined, slope of any line parallel to y-axis is not defined. Okay, I think it's clear to everybody. This is going to be used further in this particular theorem. Let me just see how we go about it. Okay, just listen carefully. Now let me think about the statement, Rolle's theorem. Okay, the statement goes that okay, let me think about the statement. If a function y is equal to f of x is subdivision 1 continuous in the closed interval a comma b, subdivision 2 is differentiable in the open interval a comma b, then third condition, f of a is equal to f of b is equal to 0, then this symbol is called there exists, okay, there exists at least one C element of the open interval a comma b such that f dash of c is equal to 0. Let me just recall the statement once again. If a function y is equal to f of x is continuous, recall this. I haven't written the full sentence. That's a full word. Continuous in closed interval a comma b is differentiable. It's written halfly, okay, half written. Differentiable in the open interval a comma b. F of a equal to f of b is equal to 0. N values are equal. That is, the points are on x-axis. That's the meaning. Then there exists at least one C element of a comma b such that f dash of c is equal to 0. This is the statement. Now I am forced to rub the board because I have to use the board for proof. Proof is not there in most of the boards. Okay. Still, if you know the meaning of how it goes about, it's easier for you to follow. Okay, just listen. let me think about a comma 0, b comma 0, be 2 points on the x-axis, because f of a is 0, f of b is 0, therefore those are 2 points. By continuity, the geometrical meaning tells you I am able to draw the graph without any break between a and b. That's the meaning. Okay. By differentiability, you mean, I repeat, by differentiability, you mean the slope of the tangent at each and every point drawn in between a and b. It is a finite quantity. That's the meaning. If I keep on drawing various tangents, okay, if I keep on drawing various tangents in between a and b, okay, the slope of the tangent will be, geometrical meaning of derivatives tells you slope of the tangent is a finite quantity. If I keep on drawing various tangents, okay, I can keep on drawing various tangents, okay. If we keep on drawing various tangents in between a and b, okay, the slope of the tangent will be definitely a finite quantity. That's the meaning of differentiability. Okay, derivative exists is the meaning of differentiability. Okay, then listen carefully. Due to the continuous nature of the curve, if I keep on drawing various tangents, at least at one point definitely, okay, if the curve is like this, I'll get only 1 point. If the curve goes like this, I'll get 3 points. I'll get 3 such points. Okay, there are at least one. There is 1 point, and I get 3 such points like this. Okay, at which the tangent drawn will be parallel to x-axis. Okay, now this point is c comma f of c. By geometrical meaning, what is the slope here? It is f dash of c. So it is parallel to x-axis. Any line parallel to x-axis will have slope to be 0. Therefore, I'll get f dash of c is equal to 0. I repeat the proof again. A comma 0, b comma 0 are points on the x-axis, because f of a is equal to 0, f of b is equal to 0. Okay, then by continuity I will be able to draw the graph of the curve between a and b without any break. That's the meaning of, geometrical meaning of continuity. Okay, by differentiability in the open interval, okay, if I keep on drawing various tangents in between a and b, none of the tangents will be parallel to y-axis. If it is parallel to y-axis, slope will be not defined. Therefore, it will never be parallel to y-axis. Therefore, slope will be a finite quantity. Slope of any such tangent will be parallel to none of the tangents will be parallel to y-axis. Slope will be a definite finite quantity. That's the meaning. Okay, due to continuous nature of the curve between a and b, okay, and f of a equal to f of b is equal to 0, that is also important. F of a equal to f of b is equal to 0. Okay, I mean to say automatically at least 1 point, there will be a point c at which the tangent drawn is parallel to x-axis. The slope here is f dash of c, and since it is parallel to x-axis, slope is equal to 0. F dash of c is equal to 0. Therefore, I will get a condition like this, a condition like this. If f of a not equal to f of b, listen carefully, you may get a curve like this. Therefore, there will be no such turning point over here. Then automatically I can't think of the tangent parallel to x-axis. It stops before turning point like this. That's the reason why I need to have f of a equal to f of b is equal to 0. I may get 1 point or more than 1 point. Looking at the different types of graphs over here, we are going to think about. Then after that, the third condition, f of a equal to f of b is the must, but equal to 0 is in fact optional. Just listen, because if they both are equal, automatically there will be a turning point like this. But if equal to 0, the points will be on x-axis. Otherwise, the points will be above x-axis. For the third condition, equal to 0 is optional, but f of a equal to f of b is a must. Okay, it's very important. This is how the proof goes. This is how we think of the proof of Rolle's theorem. This is how we think of the proof of Rolle's theorem. Then let me go to one of the problems at least. Okay, verify Rolle's theorem for y is equal to f of x equal to x square minus 7x plus 10 in the closed interval 2 comma 5. Just listen carefully. Answer: y is equal to f of x equal to x square minus 7x plus 10 being a polynomial function. Being a polynomial function, it is continuous. It is continuous in the interval 2 comma 5. Okay, now dy by dx equal to f dash of x is equal to 2x minus 7 is a finite quantity. is a finite quantity in the open interval 2 comma 5. Therefore, when the derivative is finite, I mean to say the function is differentiable. Therefore, y is equal to f of x is differentiable in the open interval 2 comma 5. Then what is f of 2? 4 minus 14 plus 10 is equal to 0. What is f of 5? 25 minus 35 plus 10 is equal to 0. F of 2 is equal to f of 5 is equal to 0. Therefore, required three conditions, required three conditions of Rolle's theorem are satisfied. Therefore, there should exist at least one C element of open interval 2 comma 5 such that f dash of C is equal to 0. I should find such a C. Let me write over here f dash of C is equal to 0 implies 2C minus 5 is equal to 0. C is equal to 5 by 2, which is anyway 2C minus 7, 2C minus 7 is equal to 0. 2C minus 7 is equal to 0. Therefore, C is equal to 7 by 2, which is 3.5. 3.5 is an element of 2 comma 5, the interval 2 comma 5. Thus, give the conclusion. Thus, Rolle's theorem is verified. Let me repeat the whole process. Verify Rolle's theorem for y equal to f of x square minus 7x plus 10 in the closed interval 2 comma 5. Y equal to f of x square minus 7x plus 10 being a polynomial function is continuous in closed interval 2 comma 5. Then derivative 2x minus 7 is a finite quantity. If the derivative is not finite, it is not differentiable. At least at one point, if it is not finite, I mean to say it is not differentiable. If it is not defined at one of the points in between the interval, it is not differentiable in the interval. Now for it is function is differentiable in the open interval. F of 2 becomes 4 plus 10, 14 minus 14 is 0. 25 plus 10, 35 minus 35 is 0. F of 2 is equal to f of 5 is equal to 0. Now for required three conditions of Rolle's theorem are satisfied. When the conditions are satisfied, I should have at least one C such that f dash of C is equal to 0. Here 2C minus 7 is 0. Therefore C is 7 by 2, which is 3.5. 3.5 is in the open interval 2 comma 5. Thus, Rolle's theorem is verified. Okay. Thus, Rolle's theorem is verified. Okay. I think it is clear to everybody. Let me think about one more example. Okay. Verify Rolle's theorem for y is equal to f of x equal to sine 2x in minus pi comma pi. Okay. Then answer y is equal to sine 2x being sine function is continuous in the closed interval minus pi comma pi, or you can say the sine function is continuous, 2x being polynomial function is continuous, sine 2x being composition of continuous functions, that is also correct. Either way you can write, both are correct. Okay. Then dy by dx equal to f dash of x equal to 2 cos 2x is finite, the open interval minus pi comma pi. Therefore, f of x equal to sine 2x is differentiable in the open interval minus pi comma pi. Then f of minus pi is equal to sine minus 2 pi is equal to 0. F of pi is sine 2 pi. At every multiple of pi, sine is 0. Therefore, the required three conditions of Rolle's theorem or satisfied. Okay, therefore there should exist at least one C element of open interval minus pi, pi, comma pi, such that f dash of C is equal to 0. Okay, just listen. Now, if dash of C is equal to 0, let us see. What do I get? I will get 2 cos 2C is equal to 0. Cos 2C is equal to 0. 2C is, let us say, at every odd multiple pi by 2, cosine is 0. Therefore, I take it to be 3 pi by 2 minus pi by 2 plus pi by 2 plus 3 pi by 2. Therefore, C becomes minus 3 pi by 4 minus pi by 4 pi by 4 3 pi by 4. I can even take minus pi by 2 and minus plus pi by 2 also. But pi by 4 is 45 degrees. 5 pi by 4 is beyond 180 degrees. Therefore, these are all the values in the open interval. Let us say minus pi, pi. Here I am able to get more than 1 point. I am able to get 4 different points. Thus, Rolle's theorem is satisfied. Thus, Rolle's theorem is satisfied. Sorry, verified. Thus, Rolle's theorem is verified. Sorry, Rolle's theorem is verified. We just repeat the whole process. Y equal to sine 2x being sine function is continuous, or sine function is continuous, 2x being polynomial function is continuous, sine 2x being composition of continuous function is continuous. If dash of x 2 cos 2x is a finite quantity or is finite in the open interval, therefore function is differentiable. Okay, then f of minus pi, at every multiple of pi, sine is 0. This is 0, this is 0. If f of minus pi is 0, f of pi is 0. Now for the required 3 conditions, Rolle's theorem is satisfied. There should exist at least one C, so the f dash of C is 0. Now 2 cos 2C is 0. Cos 2C is 0 by 2, which is 0. You can even write 0 by 2. 0 by 2 is equal to 0. Now for 2C is, this is, I can even think about minus pi by 2 and 5 pi by 2 also. But dividing by 2 gives you minus pi by 4 and 5 pi by 4. But 5 into 45 degrees beyond 180 degrees. Minus pi into 45 degrees below minus pi. Therefore, I eliminate those values. These values are in the open interval. This is minus 135 degrees, minus 45 degrees, 45 degrees, then 135 degrees. These are the values in the open interval. Therefore, I am able to get, the condition says at least one C, but there are 4 values I am able to get here. Thus, Rolle's theorem is verified. This is the way the answer is being done. Okay, we'll meet in a different video. Thank you, students.